Hello, welcome to Engineer's Edge GD&T applications. In this example, we're going to define straightness of a surface. And the particular application we have is a follower wheel, and that follower wheel will assemble and mate with a cylindrical cam feature. Now, in the upper right view, this cam wheel will translate left and right, and the design requirements are that as our cam wheel translates left and right, that we will not realize a variation of 0.002 vertically during that translation. Now, the height is not critical of this cam wheel, so we're only concerned with the translation in the vertical direction as we translate left and right. So the way that we would approach this is first to appreciate and understand that our cam wheel will only contact in a range of area on this cam follower cylinder. So we would determine what that area is by CAD or analytical methods, and then we would define that area on our drawing. Now first, let's go ahead and define the size of our cylindrical feature. And what we're going to say is some diameter, d sub 1. And then to illustrate that our effective height of our cam follower wheel is not that important, I'm going to say plus or minus 30 thousandths. So that's quite generous. Now, for this example, we're going to assume that the cam follower wheel has been properly defined in another engineering drawing, or this is an OEM component that meets our dimensional specifications and requirements. So we'll assume it's perfect. So we will need to define where those areas are that our cam wheel will contact on our cam follower shaft. And to do this on our engineering drawing, we might use some phantom lines or center lines and show in the end view where they are. Additionally, I like to define these areas in other views where it makes sense. We don't want to clutter our engineering drawings and confuse folks, so make sure that that area is clear. Now I'm using a chain line in the lower right view, though you may choose to use a phantom line. You may also want to cross hatch that area to clearly indicate where it is. Using limit dimensions or other methods, we might indicate the relative height of these intersection points as well as these surface locations. So here I'm just going to say 2 times, I'm going to say y sub 1 in this view, and then to indicate where the upper line area is, I'm going to say 2 times y sub 2. Now my x directions from the center of my cylindrical cam follower to my perspective intersections will also need to be indicated using whatever methods is best. I'm going to say X of 1. And I'm going to leave it at that. You know that you need to complete the definitions and locations of these X and Y locations. There will need to be some tolerance given to these intersections. And I would define this cam follower area at some size larger than we need. And this way, we know that manufacturing and quality will ensure these areas will meet our dimensional specifications and limit our vertical translation to that 2000s. But moreover, we're defining these areas so that in the event that we have a nonconformance in a uncritical area, let's just say in our upper right view that we ended up with a large variation in the lower regions of the cylinder that exceeded that 2000s straightness, we would not want to scrap the part or have to write a nonconformance report to accept the part if that dimensional discrepancy is irrelevant. So to define the straightness that we require, we would indicate in the view, that we want those straightness lines to run parallel to. So I want to indicate to the upper surface of this cylinder in the bottom right view. And if you recall, the fundamental definitions of straightness is that the straightness tolerance is applied in the view where the surface element is illustrated as a line, and those straightness tolerance lines will run parallel to the surface as illustrated as a line. Now there's additional information we're going to need. In my bottom left view, what I'm going to do is I'm going to assign labels to these intersections of my cylinder and my tolerance boundary area. So the lower right hand location I'm going to declare as location A. My upper right I'm going to declare as location B. And I want to give a unique name to my upper left. I'm going to call this location C. And then my lower right location, I'm going to declare this D. So, beneath my feature control frame, my straightness of 2000s, I'm going to indicate where this straightness tolerance applies. So, I'm going to use the between symbol. And I want that straightness of 2000s to occur between B and A, as well as between C and D. Now, just for clarity, and this is not required, but you might consider utilizing either a delta note or a flag note, and that note might say something to the effect that the indicated straightness tolerance shall only be applicable in the crosshatch area. And this will ensure that manufacturing and quality is focusing on those areas most critical to the function of this particular component. Thank you for watching.